Alrighty, folks, big day today. These are the last notes I'm giving you for 2020, the year of the pandemic and learning math in your room. I'm going to do all of 13.6. It's going to be your responsibility this week to kind of be able to do both law of sines and cosines and know when to do each. So let's do a quick rundown. We have been studying triangles for a long time, in fact, pretty much the whole entire quarter. And the majority of our quarter went to these guys. These guys are right triangles. And in right triangles, we have a 90-degree angle. So we used things like SOHCAHTOA to find sides. We used inverse, sine, cosine, and tangent to find angles. And when we would do area, which we really didn't do much of, but if we did, we would do 1/2 base times height, because we in a right triangle have a base and a height that are perpendicular. So that's old news. Then last week we started talking about non-right triangles, meaning obviously they don't have a right angle in them. And so in non-right triangles, one of our options was to do the law of sines. And we could use the law of sines to find sides and angles. But the deal here, and the law of sines looked like that, the sine of angle A over little a has the same ratio as the sine of angle B over B and the sine of C over C. So the catch there was that we needed a big A and a little a, big B, big C, little c. And obviously they don't have to be A, B's, and C's, but they had to be across from one another. So if we had this non-right triangle and this was A, we needed to have little a in order to solve for the other parts. So we always had a pair that was given, and that was the only way that we would be able to use this. This one came with a big, bad, ugly issue, and that was that ambiguous case. And the ambiguous case meant there was a potential for two triangles or possibly none. And the two criteria for that is that you had to be given two sides, one angle. And secondly, if you checked that box, the second thing was that the side across from the angle, so that means that they would have the same letter, just like in this little picture up here, it has to be shorter. So it's going to be shorter than the other given side. Now that's all in the name of review and kind of rethinking. And this can kind of be tricky. So you do have to work your way through that. And if you haven't really mastered that, then that's something I'd go back and look at. Okay, well, then what's over here? What if we don't have this? What if it's not a right triangle? We don't have this. Ooh, I forgot. Our area formula associated with this one, when we know two sides and an angle, and the angle is the one they form, it would be 1/2 and then A, B, sine of C. And again, don't be obsessed with what A, B, and C are. Just keep in mind that these are going to be the two given sides. And this is going to be the angle between them, not just any random angle. It has to be the one they form. So if you had a triangle and this was angle C over here, these would be like angles A and B. So side A and side B would be the ones forming that angle, and that's the situation you have to be in. And you'll know that because they'll each be different letters. It doesn't matter what letters they are, but you'd have 3 different letters indicating that the two sides you have are not the one across from the angle, or it would have the same letter. So that's also old news. So this was basically 13.0 to 13.3. Then here in 13.5, we did law of sines after we did 13.4, where we learned calculator stuff. And then in 13.6, we're going to learn the law of cosines. So the law of cosines is kind of your catch-all, because here, if you don't have a right angle and you don't have a pair, then you're going to need to use law of cosines. A lot of times after you find a pair, you'll kind of circle back around and use the law of sines to find the rest. But the law of cosines sort of gets you unstuck. Now, it looks giant and overwhelming, but here's what you need to know about this thing. In this situation, you're going to be given a variety of different pieces of information, just not a pair that you would need. So you're going to be in a situation to have to do two things. One, find a side. Two, find an angle. And three, find an area. So we have an area formula associated with this one as well. Here's what I would know. These two letters do not need to be C's, but they do have to be the same. So if you are looking for angle B, side B has to be out here. If you are looking for angle A, side A has to be out here. If you're looking for side B, then little b squared has to be here, and then angle B has to go there. So they always have to be the same letter. And then one of them is the unknown. So either we're going to be looking for this angle because it's a capital, or we're going to be looking for this lowercase, which is a side. And then once we have that, we'll be able to use the law of sines. These other letters in here, I don't care if they're A, B, C's, or P, Q, R's, these are going to be the two other sides that you're given. Now, like always, it'll make more sense when we do an example, so stick with me. And then the area formula that I'm going to show you, and I'll probably show you that first because it goes a little bit more quickly, is called Hero's formula. Some will call it Heron's formula. I don't know that one's right or one's wrong. Here's what it looks like, and you actually have seen this in geometry, so don't pretend you haven't. It's going to be the world's biggest, fattest square root sign, and then you're going to take S times S minus A, S minus B, and S minus C. That, my friends, is your formula, where A, B, and C are going to be the three sides of the triangle. So that means that here you would need side, side, side to find the area, whereas down here you have side, angle, side. So that takes care of the A, B, and C. What's S? S is going to be the semi-perimeter. So semi-perimeter is exactly that, half of the perimeter. So the perimeter, we know from geometry, would be all three sides added together, and then semi would be divided in half. So it's not complicated work, but it's just a little bit of kind of futzing around. So let's take a look at, and I'm going to do the examples that you will find in the note packet. So if you're looking at the notes, number 4 is asking me to find the area, and it's giving me that A is 5, B is 8, and C is 11. So when I look at that, that's obviously all three sides. And so one of the things I'm going to need to know then is, okay, which of my area formulas can I use? Well, I don't have side, angle, side. I have side, side, side. So I'm going to use that new formula we just got. So the first thing I'm going to need is to find my semi-perimeter. I'm going to add my three pieces together and divide by 2. Make sure that if you're doing this on your calculator and you don't want to do separate steps, make sure you're using a parenthesis to say 5 plus 8 plus 11 and then divide by 2. Because if you do 5 plus 8 plus 11 divided by 2, it only divides the 11 by 2 and it gives you a really messy wrong answer. So in this case, my semi-perimeter is 12. And then my formula is to take that semi-perimeter, multiply it by that same semi-perimeter minus each side length. So I'm finding the difference between the semi-perimeter and each of the sides. So I put up my big old square root. My S is a 12. So then I have 12 minus side A, 12 minus side B, and 12 minus side C. And you can do however much of this you want in your calculator. I usually try to make it not quite so messy. So I would have 12 times 7 times 4 times 1. And then I just do the part that's under the radical. You can do it however you'd like as long as you use all the right keystrokes. So I'm going to get a 336 under the radical. So then I'm going to square root it, which is the same as a half power. So I get 18.33, and the instructions say to round to the nearest tenth. So 18.3 is going to be the area for that particular problem. Okay, so there's a second example in the notes, but I think you can probably manage that, and you can see it in the filled-in notes if you want to look through one more of those. All right, let's get to the nitty-gritty of how to use the law of sine, or excuse me, law of cosines to find sides and angles, because that's where the real dirty work is. So I'm going to go back again and use an example off of the packet so you can look it up. So it's telling me to solve triangle WXY. So like always, I'm going to go ahead and write out my letters here for angles, and then straight across from that, write out my lowercase letters for sides. So if little w is 8, little y is 10, and x is 48 degrees. Okay, so I can't use the law of sines because I don't have a pair. So without a pair, I'm going to go ahead and solve for whatever I can. And in this case, because I've been given this angle, this is going to be the thing that I can find. So I'm going to be thinking back to my formula, which is here, but I don't have A's, B's, and C's. So if I'm going to know angle x and I'm trying to find little x, I'm going to set it up like this. X squared equals, and then my notes say that these are the two other sides. So since I know the two other sides, I'm going to have an 8 squared plus the other side, so a 10 squared, minus 2 times each of them, so 2 times 8 times 10 times the cosine, because I'm switching to the law of cosines, and then the angle. Now, this one is easier. So this is when I'm going to find a side. This is my unknown, and everything over here is a number. So you type this whole big giant thing into your calculator as 1. So I'm going to go 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 48 degrees. So my x squared comes out to be 56.9, but keep in mind that's x squared. So I need to square root that, and I don't have to do a plus minus in this case because I am finding the length of something, and so it can't be negative. So I'm finding 7.54. Round to the nearest tenth, it says. Okay, so x is going to be 7.5. All right, so looking at my other numbers, that seems reasonable. It's not really long or really short compared to them. But as I said back in the notes, once you do the law of cosines one time, you can switch back over and start using the law of sines, because now I have a pair. So I'm going to find an angle. When you're finding an angle, my advice to you so that you don't get weird answers is to always find the largest angle first. So if you have a choice, and like we do right now, we could find W or Y. We're going to pick the largest one. And the way I know this that Y is going to be larger is that this number is bigger. I can see that this is my short, medium, and long side. So Y is going to be my longest, or excuse me, my largest angle. So in this case, I'm going to look for angle Y. I'm going to use my law of sines now. I'm going to have the sine of 48 degrees over 7.5, now that I have a pair, equals the sine of y over 10. And once you've used the law of cosines, you will not have that ambiguous case, so you don't have to worry about getting no triangles or two triangles. That does not happen with the law of cosines. So I'm going to go ahead and do my cross multiplying. 10 times the sine of 48, and then I'm going to divide that answer by 7.5, keeping in mind that I am looking for the sine of the angle right now. And so I'm going to have to use, since I'm finding an angle, sine inverse. Every time you're looking for an angle, your last move is sine inverse, or we'll use cosine inverse in a minute too. So inverse sine of that answer gives me that angle y is 82.2 degrees. Okay, so if angle y is 82.2 degrees, I do not need to use law of sines to find that last one. I just have to remember that these total 180. So if 180 is my total, I'm going to take away the 48 I was given and the 82.2 I just found, and that will make this one 49.8 degrees. So I have solved the triangle. I have found all the angles and all the sides using law of cosines to find the first side, law of sines to find an angle, and then just the fact that the angles add up to 180 to find that third angle. Okay, So earlier in the video, I said we were going to learn 3 things: how to find area using our hero's formula, how to find sides using the law of cosine. So the only thing we have left is how do I find an angle? So let's do one of those, and then we will call it a wrap on our last notes of the year. I know you're sad. It's okay. If you email me over the summer, I'll send you some math videos if you'd like. All right, so number 2 on your notes packet says triangle J, it says triangle H, J, K. So H, J, K, H, J, K. Then I'm going to write in what I know. And the reason I like to do this is once law of sines and cosines is mixed, I can quickly see what I was given. I was given little h, little j, and little k. So this obviously has to be a law of cosines problem, partly because it's the law of cosine notes, and partly because I don't have a pair. So I need to pick an angle to find first, and I'm going to take my own advice from the previous problem and find the largest angle first, which I know is going to be h because this is my short, I lied, it's going to be j because this is my short, medium, and long side. So the first thing that I have to do is I have to find angle j using the law of cosines. Now, this is going to be a little tricky. I'm using that same formula. Keep in mind the formula looks like this. But I don't have A, B's, and C's, so I have to think, okay, I'm trying to find angle J. So if I have a J at the end, I need to have a J at the beginning. So that means 16 squared goes here, and then the other 2 sides, and it really doesn't matter what order, will go into the A and the B spot. So what I don't know is this part. This part right here is like my x. That's the unknown. So you can't just put all the numbers together. If you had like 7 equals 4 plus 2 minus 3x, you can't just do everything together. You can leave this one number, you can do these 2 numbers, and then work your way from there. Then you'd take away your 6, now you'd have 1, then last you would divide by your number that's attached to x. Keep that in mind. That is algebra 1, and that's where we're at right now. We can't just take all these numbers and put them together. I always say you can do the law of cosines waltz. A waltz goes 1, 2, 3, 1, 2, 3, 1, 2, 3. So you can do this one number, so 16 squared. Then you can do these 2 numbers, because just like here, these 2 numbers can go together. So 14 squared plus 9 squared. So those make 277, just like these 2 made the 6. And then you can do these 3 numbers. So 1, 2, 3, 1, 2, 3, because they're all multiplied by that x. So I'm going to have 2 times 14 times 9. And keep in mind that was negative, so minus 252 cosine j. So now I'm kind of here. I have a number equals a number minus something attached to my x. What did we do next? We subtracted the number. So that's what we do here. We do that every single time. Obviously, the numbers will be different, but the process will be the same each time. So if you practice that, it'll become pretty easy. So then I've got that over here, and my negative 252 cosine j is still over there, just like after I got rid of the 6, the negative 3x was there. What did we do next? Divided by the number attached to x, so we're going to do the same thing here and divide out the negative 252. So I'm going to take my negative 21, divide out the negative 252, and I end up with a weird decimal, which is good because keep in mind, I'm looking for the angle, but I'll have to use inverse to do that. So I'm going to do inverse cosine, because I'm using law of cosines, not sines, of that answer. And it's going to tell me that angle J has a measure of 85.2 degrees. So that's kind of a doozy. We're going to end the year with a good one. So 85.2 degrees. But as promised, you should never have to use the law of cosines more than once, because now I've got a pair and I can say sine 85.2 over 16 equals, and I'll go ahead and find h next. sine h over 14. And now I'm just using law of sines. 14 times the sine of 85.2 divided by 16. And then I'll have to do inverse sine of what I got in order to get my actual angle. So inverse sine of that answer tells me that angle H is 60.7, rounding off, degrees. So if this is 60.7 degrees, then I'm going to keep in mind that these add up to 180. So again, I use law of cosines once, law of sines once, and now I should just be able to say what's 180 minus the 60.7 and the 85.2 that I've already used. 34.1 degrees, which matches because this is the shortest, or excuse me, the smallest angle, the medium angle, and then the longest angle. So that's a lot, but totally doable. And that's what you're going to be practicing. You're going to have a Go formative, and you're going to have a quizzes. And then on Thursday, I would really like to be able to see everybody real quick in the meeting room, and we'll pick a time. I'll make sure that's on the weekly plan since it's the last day of school. And we're going to do something pretty easy because it's the last day of school. You don't have to take a final exam. And you have rocked it during online learning and really stuck with it. The vast majority of you guys have been awesome. So that's it. Now you know everything you need to know to be awesome pre-calc kids next year. Talk to you soon. Bye.